Hello. In this video, I'll be describing the linear modeling project for intermediate algebra. The point of the project is to understand how lines or linear modeling can be used to understand relationships between two variables, real-life variables in society, X and Y. So it's up to you to pick what X represents and what Y represents for you. In this particular video, I'll be making a sample project where I will try to see if there's a relationship between academic performance in Los Angeles cities and the pollution burdens, so the quality of the air. So those are variables. Those are examples of variables, quality of air. Another example of variable would be median household income, for example, or the academic performance index of a particular racial group. It's up to you what two relationships you want to explore. You do have quite a bit of options here. I also have a database involving medical costs, which you can also explore. Like I said, in this particular instance, I will be establishing or trying to establish a relationship between these two variables that I mentioned already. So the first one is involves the map of Los Angeles pollution burdens, which is published by USC, which is right here. You can see you can click on any town and it'll give you the pollution burden score. Okay, so I'm going to try to establish a relation between that and the academic performance index, which basically tracks how well students do on standardized exams at LA's high schools or middle schools or elementary schools. I actually have the Excel data downloaded for you, but if you're interested in learning more, you can go to the website, which gives you more details. You'll have to go under the data files and record layouts. Keep in mind the data that I have provided for you, the Excel file, is for 3-year average APR scores up to, I think, 2014. So these are definitely dated, and so this research project isn't going to be the most scientific one at all. I also have, by the way, information. Citydata.com really is a great website for searching information about cities. So, for example, let's say you're interested in the data for city of Burbank. You can type Burbank and then city data, and that would give you Burbank's information. So some of the items you can pick up is, first of all, demographic information, crime rates, and financial information like median gross rent or median household income, and broken down as well by gender. So this is cool stuff. And if you do this, you'll have to do this for several different cities. So these cities are going to represent rows, and we're going to have 2 columns of data. Okay, so let's get right to it. Okay, like I said, I promised what I'm going to do is explore the API score. So let me open up the Excel file. Now, I do recommend that you work both with Microsoft Excel, with Microsoft Word, as well as Desmos. So you're going to be working with all 3 tools here. So your final report should be in Microsoft Word. So let me open up a Word file as well. Now, your final report should be typed up within Microsoft Word. So I'm just going to open up a blank document here. But you should also have a document where you're working with an Excel file, a completely fresh Excel file here. So now let's first understand the API score data. Okay, over here on top, as you can see, you have these columns which have these fancy, weird looking titles. To learn about what those titles mean, you'll have to go here where be sure to check out the record layout. There it is. So it gives you kind of a legend on what those titles mean. And what I'm going to use is this one, the 2013, excuse me. I'm going to use, let's see. The 2013 Growth API is a good one to use. So it stands for API 13. But I was looking for one where it actually has the weighted 3-year average. There it is. This is the one I want to use because it basically takes the average of 3 years and gives you the API for that. So I'm going to use AVG_W. But as you can see, you can also look up data on particular racial minorities, well, broken up based on racial minorities. And you can also, based on socioeconomic disadvantage, or students with disabilities. So the API scores for those particular social groups are available here. Okay, whether or not they might be interesting for you or useful. So anyway, what I'm just going to do is pick the 3-year average, AVGW, which is in the Excel file here. Let me open it. What happened to the Excel file? There it is. So AVGW, that would be somewhere here. Okay, there it is, this particular column. So I'm going to highlight this, this whole column. There it is. So I just clicked on the top here and I clicked on the yellow so that I know that I'm working with this. You are welcome to delete all the other columns if you find them, kind of, or hide them rather. So you could, to do this, you can, by the way, highlight all of these columns. Okay, and then you just right click on top there, and then you just click hide, and then it hides all of that for you. And then you could do the same thing here, by the way. And then these ones we can also hide as well at the moment. Well, the county might be useful to have, so I'm just going to keep that. Okay, so now that this is easier to read, we can also delete these because they're technical data that we don't really need. So these are the names of the high schools. These are the counties that were or schools. These are the counties, and these are the scores. Okay, AVGW. So that's what we're going to do. All right. So what I'm going to do is start by titling my Excel file. So it's going to be city, okay, pollution burden, okay, and then API score. So these are going to be the sort of the titles of my columns, right? So make them bold if I want to, and that's it. All right, so here we go. So first I'm going to pick a city, and this is, technically as a scientist you should be doing this randomly, but since we're not scientists, I'm just going to go ahead and pick a couple. So I'm just going to pick an area of Pasadena here. All right. So let me pick up particular Pasadena score 6.176. There it is, 6.176. Okay. So I'm going to switch back to Excel. I'm going to write Pasadena. Then I'm going to write 6.176. Okay. And now I need to pick the API score for Pasadena schools, right? So for that, I'm going to open up my other Excel file here. And I'm going to do a Control F. I'm going to do a search for Pasadena. Okay, there it is, Pasadena Unified. Now, this is a bit tricky here, right? You could, these are all API scores of all the schools in Pasadena. So now, since we're interested in pollution, I might want to pick all the elementary schools. So here are the elementary schools in there. Okay, so it's up to you. If you want, you could make it easy on yourself and just pick one school. I'm gonna do something a little more technical. I'm gonna pick all the elementary schools here. Okay, I'm just gonna copy that and paste it here somewhere. Okay. And then basically what I want to do is I want to find the average of all this. So I'm going to write equals average, and then I'm going to say DE 3462 all the way to 3475. Well, there are a couple of these data points are need to be emptied. So I'm just going to delete this. They're empty, so that's why it's unable to calculate the for some reason they're empty. So let's try again. Average of DE 3462. DE is the name of the column, all the way to DE 3472. 3. Okay. Well, that didn't work for some reason either. Okay, so I figured out what was going on. Basically, the numbers were being stored as text. So let me fix that. So I'm going to highlight that again for the elementary schools. Okay. And I'm going to post this in my full document here, which is right here. So I'm going to post it. And making sure I'm picking all the Pasadena schools. Okay, that should be all the elementary schools. Okay. And I will paste this. Okay, so then I just need to click here and make sure I need to convert this to number. I need to convert these to number because it's not they're not being considered as numbers. So now I'll do a average G1 through G12. Like I said, you don't actually have to do this. You could just pick one, but this is the average API for all the elementary schools in Pasadena. So that's the number. I'm just going to put that here. Okay. We'll try that again. I'm going to paste the value. So I just right click on that, paste the value, or you could just do that by hand. Okay. So I just finished one data value for Pasadena. So now I'm going to do another one. Okay. So let's try that again. So I'm going to pick another city. So this time, let's pick a different city, maybe a city where it's a little bit more dirtier or cleaner than the one we just had. Let's see. Let's try maybe Granada Hills. Okay. So Granada Hills 5.058. All right. So let's open that up. Let's type Granada Hills 5.058. Now I need to get the API score. All right. So I'm going to type Granada Hills here. All right. There we are. And again, I want the Granada Hills this is a little bit harder because they're not organized by Granada Hills, but I'm going to pick Granada Hills. Let's pick for elementary schools. Okay, so this is definitely a challenge because now there's a bit of an inconsistency in terms of like, is it Granada Hills elementary school or high school that we want? In this case, I'm just going to pick the high school here, which is 880. So I'll put that here. So you can see now I've introduced a bit of an inconsistency in my data because this value is for elementary schools and this value is just for one high school. So this is definitely super unscientific. But I'm just showing you that, of course, you could run into difficulties if you want to do this properly. So more properly, if we wanted to do this, we should have found the list of all elementary schools within Granada Hills, and then we would take the average of those. So to avoid the next problem, what I'm going to do is pick actual cities. So like in this case, let's pick Glendale, because Glendale actually has its own school district. So that way I can organize it better. So, so let me just pick a particular spot like 6.278. All right, so Glendale 6.278. You can see there's another issue because up here, this is northern part of Glendale right here, and definitely the air is cleaner there. And I'm not sure whether we're going to be able to separate the schools that are in northern part of Glendale compared to southern part of Glendale. So if you were doing this properly, that's what you should do, looking at the actual location of the schools. So again, another scientific issue that we're kind of glancing over here, but if you wanted to be precise, you really should do a better job than I'm already doing. But again, this is for illustration's sake. So I actually happen to know the Glendale schools, so I will try to do a good job. So let's look for Glendale Unified. All right, so here are the schools. So I'm going to pick the elementary ones. Now, I do know that Dunsmore is up in northern part of Glendale, so I'm going to exclude that. So let me pick the ones that are not in the northern part of Glendale. So let me post that here. And I'm going to post that here. So I'm doing Control C and Control V in case you're wondering. Yeah, these are all at this point pretty much in the northern part. So I'm just going to get the average of these. So again, convert to number, and then I'm going to type average J1 through J11. If you want to avoid having to do this, one thing you could do is look up the specific location of the high school or middle school that you want to track down, and then look up the pollution burdens in that particular location. So that way you don't have to do averages. I think it's of course better to do averages, but all right. So this was South Glendale. Okay, so let's do one for North Glendale. Looking at the pollution burdens. So North Glendale would be something like this, 5.02. So, all right, and then let's get the scores of that. So there's one. There's another. That copy process didn't work for some reason. There we go. There's another. You can kind of see these values are higher than the ones we were working with. All right, here we go. So average L1 through L. Oops. Oh, I forgot to convert to number. It pastes it as text for some reason. I don't know why. Okay, 912. So I'm going to go put 912. So now, how many should we do? Right? Technically, you should do at least 20, or rather 30, actually, if you want to do a good job. But for the purposes of this class, I would recommend at least 10. So again, technically, if you're not doing 30 rows, it's not going to be super scientific. Of course, this whole thing is not super scientific because we're not really randomly picking these cities. And of course, you also saw how we're not super careful in terms of the actual location of these cities and corresponding to their high schools or middle schools or elementary schools. Because since what I've been doing is averaging, and in the case of Granada Hills, I didn't even do that. So, so for the sake of argument, let me pause this video, and then I'll collect a little more data, and then we'll start doing some analysis. So I added a few more lines here: Inglewood as well as Santa Monica Unified School District, and luckily Inglewood and Santa Monica were different school districts. So the odd one here is Granada Hills. I'm just going to keep it here because we don't have a lot of data, but normally I would want to avoid having that discrepancy. So now what we're going to do, next step, is we're going to open up Desmos, and we're going to transfer this data there. So there are two ways to enter this data within Desmos. Okay, so one way to do it is simply to you want to, by the way, title this. So linear project, linear modeling. Okay. So you're going to go to plus sign and then choose table, and then here you would just enter those scores we were just working on, which is you would enter these numbers, right? So for example, you would enter this number here, 6.17, 6176, and then this number 803.69 you would enter here. That's one way to do it. Another way to do it is you should be able to copy and paste this. So let's see. Let me just select that, then come here and then paste it. So if you're just at the regular f of x expression kind of line, okay, so what you do is just do Control V, which is pasting it, and then you just paste that. Okay, so here's the data that we're looking at now. You won't always be able to see the data. You might not be able to see these dots. To make sure that you see the dots, be sure to go over here and be sure that your domain for the x-axis and y-axis are set up properly so that you can see it. So for example, notice that Desmos automatically set up my x-axis to range from 3 to 10 roughly, which represents the pollution burdens, and my axis, it's set up to range from 600 to roughly 1,000, which were the API scores. So make sure that those are set up correctly, otherwise you won't be able to see this part of the screen. So now this is the hard part, right? What we want to do is create a line. So let me go back to the instructions for the project. We're pretty much done with step one, which was really honestly the harder part of the project, the hardest part of the project. And so we're done with that. And by the way, now that we have this, we can put this in our project, by the way. So remember, I opened up a blank Microsoft Word file. Here it is. So keep in mind, you can actually just Control V paste your data set into Microsoft Word, right? You want to have that. So you can just say, for example, here is the complete data I collected. And you have the data down here. So that's pretty cool. And then what you want to do is you also want to include, well, of course, you want to also include like a little sample introductory paragraph, right? So like you want to have like a little introduction here. Then you have your data. And then you can have the scatter plot also that we just obtained from Desmos. So in Desmos, here's the scatter plot. you can just go to share, and then you choose export image, and then it gives you the plot. And then you can just different styles here if you wanted to, and then you can right click copy image, and then you can just Control V paste it. You might want to adjust this here because it looks too big, but that's how it is easy it is. You can also save this as a PNG, and then within Microsoft Word you can go to insert picture and then choose that. But here all I did is once again I right clicked on this image, chose to copy image, and then over here I just Control V pasted it. Okay, or you can just right click and then choose paste. That's another option, and then it would just paste that image. So so we have the scatter plot and we have the data. This is, honestly, one of the hardest parts of the project is just this first step. Okay, now let's see what is the second step of the project, which is I guess that was the step 2 also was getting the scatter plot of the data. Okay, so what is the step 3 then? All right, so step 3 is finding a line which passes through these points, but using the method of just picking 2 points and then using the point slope formula to find the equation of the line. So what we're going to do is pick 2 points. We just need to pick like representative points. Like we could pick these 2 points, for example. And it's super easy to do this. You can literally do this within Microsoft, within Desmos. So literally the equation is y minus y1 equals m times x minus x1, right? So you can actually type the formula within Desmos. You can say m equals, and then you just hit the / button, and then you need to enter these. By the way, they're not, they keep disappearing here, but I think there's a way to get them to not disappear. Maybe not. Maybe there isn't a way. Because this is a scatter plot. So 4.9, it won't let me. Maybe I can do a screenshot of it. There we go. 4.93, 896.3. Okay, so I just click on label, and this one was 7.628. Oh, I can see the numbers up there, so why am I even struggling? I don't know. So I'm just going to label these so that they don't disappear. And then I'm going to choose the formula for slope. So it's going to be 769.083 minus 896.3. That's y2 minus y1 over x2 minus x1, right? That's the formula. And that's the slope right there. Okay. And then I just need to type the formula, which is y minus y1, right? Which is, in this case, I'm just going to choose this one, equals m times x minus x1, which is this line. So it already remembers what my m is. And so that's the formula. Now, in Microsoft Word, you want to be more precise and actually type this formula a little bit more neatly, right? So for example, when you're typing this right here, you want to be a little bit nicer. So to do that, you can say something like, step 3, so you can say for step 3, I had to obtain the linear model by using 2 representative points, and I chose the points, and then you mention what those points are, right? You chose these points. Doesn't copy correctly, as you can see. Copies the LaTeX code, which is what this is called. Okay, and I found the slope m, and then here what you want to do is enter equation mode to make it look nice. So the way you do that is you can go to insert and then you choose equation here, okay? Or you can just press the Alt key and then the plus sign, and it enters equation mode, and then you can just type that. And then since Desmos already found the answer for us, all you'd have to do is just copy this. You don't even have to use a calculator to find the answer. So Control C and Control V, there we go. So as you can see, this looks very nice. This looks like a nice little Microsoft Word project. You do want to save this. Notice I haven't saved this. So let me save that. Okay. So, okay, so sample project. Okay. Okay, so now we and we also found the line, right? We actually have the equation, which is what this is. So I can copy that. Now I want to remove these m, so I can just, and instead of m, I can just type this. Notice I rounded that number. So okay, so there it is. If you want this to look nicer, you might want to enter this in equation mode, which is what I'm going to do. So I pressed Alt plus and I entered equation mode, so it looks nicer that way. Okay, so we have found the equation which passes to these points. And this equation represents the relationship between pollution burdens and academic performance index. By the way, we haven't really discussed the shape of the scatter plot, which is really the most interesting part of the story, which is what I am interested in you having to write about, which is that notice that as we move to the right on the x-axis, the y values tend to go down, right? So this is a model which has negative slope, and this is not a coincidence. It's not a coincidence that the model has negative slope, because as the pollution is getting dirtier, right? As the air is getting dirtier, the scores are going down. Okay, so this is precisely what we would have predicted, which is that dirty air may have an impact on academic performance, whether directly or indirectly, right? So we might want to explore how it could have an impact indirectly. So that is step 2. Okay, step 3. So let's go to step 4 here, which is obtaining the manual model. So we're gonna try to use sliders to obtain the model manually. Okay. Now, what does that mean? It means that all we have to do is enter y equals mx plus b. Okay, and since I already used m here, let me change this to m1 so that way I don't have to worry about this. So I'm just going to use mx plus b here. So notice I changed the previous one into m1 because I want my m to vary now. So now I'm going to choose to add the slider. So all I did is I typed mx plus b, and then notice it asked me, let me do this again. So notice it asked me to add sliders. So I'm going to add those as sliders. Okay, so now I'm going to increase my b here. But notice that since my b values are quite large, all the way up to 1,000, maybe my y-intercept is somewhere, as you can see, it's going to be somewhere near 1,000. I need to be careful. You can see here's the red line that I'm trying to manipulate, and notice it's not really moving much because my minimum and maximum values are limited. So what I'm going to do is adjust this. I'm going to say b should be like between, let's say, 800 and 1,200 or something like that, or maybe between 900 and 1,100. Okay, and the step should be maybe 10. So that way, when I'm manipulating my b, as you can see, now I can move it up to where I'm supposed to have. But the problem with the slope is the same. So I'm going to adjust that also. So I'm going to do -60 all the way to -50. Now I know already that my slope is going to be negative, and that is the reason why I'm having it as such. So let me choose that to be negative 30 maybe. Yeah, that was okay. So now I have what I want. Almost. Let's change it to 1,400 maybe. Okay. So I can zoom in here, and what I could do is I can try to find a different line, right? Not the one we found, but one that tries to kind of fit through more of the data, right? So we want to be able to find something that kind of takes into account all the other data, and this is kind of what I'm finding. We don't have a lot of points here, so it's not really, this is not really a precise game, but you can see that we have found the slope is negative 48, which is super close to what we found when we picked 2 points. And then the y-intercept is 1,140. So this is another thing you want to record in for step 4. Okay, so let's go to step 5. This is the cool one. This is basically where this Desmos actually finds the equation for us, right? So it uses advanced mathematics, it uses statistics and calculus to do it. So to do this, this is super easy. All I have to do is enter y equals, and then I'm going to choose another variable for my slope. This time I'm going to choose m2, and then I'm going to type x times x1 plus, instead of equals, I need a tilde here. I forgot. And then b2, let me choose b2, and then x2 here. Let me see here. x1, y1, excuse me, not y1. Okay. There we go. Okay. So what I meant to type is not y1, y, but y1, right? Because I need to use the title here, which is y1 and x1. So I need to use these titles. So I'm going to type y1. Let me do that again so you can see. Let me try to do it carefully. So y1 tilde, which is the symbol underneath the escape button, right? Shift, using the shift, and then I want to use m normally, but since m is busy and m1 is busy also, I'm going to use m2 times x1, right? Y equals mx plus b, right? But b is also busy, so I'm going to choose b1 or b2 for the sake of consistency. Okay, so here's my equation, and you can see what has happened is, by the way, we can turn off the old ones so you can see the one that Desmos has found. So Desmos has found this line, which is super close to the one we found earlier also. It's not always going to be like that, but you can see the slope is negative 48 and the y-intercept is 1,134. Again, very close to the ones we found by manipulating, and very close to the ones we found by picking randomly, well, not randomly, picking strategically 2 points. So here we have, so again, what you want to do is provide a record of having done this. You could do that, by the way, by like copying this here. You could do that by hitting the, you can do a screenshot by hitting the, in Microsoft PCs, you can do Windows Shift S, and then it switches to the screen where you can highlight it, and it copies that. So that's Windows Shift S. And then within the Microsoft Word project, you can just, again, Control V. So that gives you a record of you having used Desmos to find the regression line. And you do want to write it like y equals mx plus b form, right? So you do want to write using the step, using Desmos's online calculator, which, by the way, this is called regression analysis, or regression line. I found the line to be, and then you enter math mode, and you can say, I rounded those numbers there. I just rounded these numbers. Okay, so that would be that step. Okay, so that's step 5, pretty much. That's all you had to do. All right. Now for step 6, you want to basically look at the 3 different models that we found, right? So you want to be able to say, okay, what's the difference between kind of the one we found by kind of moving things around, the one we found by using the point step formula, which was this one, and the one that we found by using the online calculator regression. And you can see the idea is that you want to be able to maybe compare these. In your particular instance, they might look different. In my case, they look super close. I would say the one we found using manipulation it has a higher y-intercept, but pretty much they're parallel. Their slopes are very close. So that's kind of what you want to comment on for step 6. And you do want to interpret it again, right? You want to say, okay, what this means is that as pollution burdens get more intense, the academic performance seems to go down, right? So that's the meaning of that negative slope. For step 7, then you're just basically writing down a kind of a summary of everything else, okay? Now over here, I do want to mention this idea of a correlation coefficient. This is a little bit over our course, but it is a value that's available right here. It's called R. The closer the absolute value of this number is to 1, the more accurate is the linear regression model. So in our case, this number is quite close to 1, right? If you take the absolute value of this number, you would get 1 almost. It's because it's 0.9. Now, what that means is that this model is quite accurate. So if your R is less than, let's say, 0.5, okay, it's closer to 0, it means that the data that you have really cannot be modeled linearly, right? So the linear equation does not represent what's going on in reality. But if your R, which is called the correlation coefficient, if the absolute value of this number is close to 1, it means the line we found, or rather the line that it found, Desmos found, is quite close, right? It means that it represents reality as best as it can. The point of this project, again, is to explore the relationship between 2 variables or 2 quantities, quantitative variables that we have in society, yeah, and to see if there's a relationship between the 2. The point of it is to realize that, in fact, algebra is quite useful in being able in understanding what is going on in our lives, right? So pollution is or academic performance is something that affects our life, right? Whereas we don't think algebra is something that can help us understand that. Where the point of this project is to realize that that is not true. Hopefully you'll have fun doing the project. Let me know if you have any questions. Hopefully that was not too fast. I wish you the best in your endeavor.